Hey everybody, there's been a couple requests for me to make this video to kind of talk about acceleration, okay? The project that we're working on right now, we're measuring acceleration and force and velocity and a lot of different stuff and putting it together to kind of keep Mr. Mark Watney alive as he falls with a parachute to the Martian surface. Okay, so the question right here says, a car is traveling down the road at 14 meters per second. The driver increases her velocity to 25 meters per second, so she definitely sped up. What is her acceleration? After she speeds up, calculate her force. The car and her have a combined mass of 869 kilograms. The way I estimated that, one of my favorite vehicles is a Volkswagen Beetle. So I found a 1970 Volkswagen Beetle, which had a mass of 819 kilograms, and then just added in a 50 kilogram person. And she was driving for 13 seconds. So a lot of good stuff there. Basically, what's happening is this lady, this is a horrible car, she is driving this car, yippee, from a starting point to an ending point, okay? And what do we know here? We know that she started at 14 meters per second. That's about 50 kilometers per hour. And then she accelerated to 25 meters per second. That's about 90 kilometers an hour. So she definitely sped up. You know, maybe she was trying to get to McDonald's or trying to get her kid to school, or, maybe she was, some kind of malandra running from the police or something. Who knows? But she definitely increased her velocity, going from 14 meters per second to 25 meters per second. And we know that this took 13 seconds. So a lot of good information there. So I like to draw a little picture to start us off. And, that kind of helps me being a visual learner. Okay, so the first thing we want to think about is, what are we being asked for? What do we want? Okay, well, we want two things. First of all, we want to calculate acceleration. So we want acceleration. Acceleration is changing in velocity. If you're increasing your velocity, your speed, you have a positive acceleration. If you're slowing down, you have a negative acceleration. And also, we want force, okay? So it's kind of a two-part question. We want acceleration and we want force right here. So I like to write down, again, what is it that I know? I'm going to switch colors here because I'm kind of switching my thinking process, all right? So acceleration, first of all, we know the formula. Acceleration equals final velocity minus initial velocity divided by the time that it took, okay? And final velocity, that's what we end with. That's right there. Velocity, final velocity. And then, what we started with, that's initial velocity, V sub I. So that's two very good pieces of information, and we actually have the time. So we have everything that we need. This is the time in seconds. So we can go ahead and plug and chug. We're going to write the formula with what we know. Final velocity, right there, was 25 meters per second. And then we subtract our initial velocity. Initial velocity, what we started with. She started at 14 meters per second. If you're starting from rest, or you're starting from not moving or whatever, then it's just going to be 0 meters per second for that initial velocity. But she was already moving, when she decided to go super fast, apparently. And then we divide it by the time that it took to do that. And we know that that is 13 seconds. Okay? Now, I've already done the math, but make sure you are bringing your calculators with you. Make sure you have your calculators in school every day. But 25 minus 14 is 11, and we divide by the time of 13. So I do the math, boop, 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 and I get 0.84615. All right, now in my class, I'd really like you guys to round to hundredths if you get a big giant number like that. So this is tenths place, the 8, and the 4 is in hundredths place. So we look to the right, and if the number to the right, which is the thousandths place, if it is 5 or above, we round the hundredths up. If it is below 5, then we keep the hundredths the same. And because that 6 is above 5, we know that our acceleration, rounded is 0.85. Don't forget units, meters per second squared. Okay, we have calculated. Remember, you always need to show your work. Make sure you always have your units and check your calculations, double check your calculations. So that means that her acceleration was 0.85 meters per second squared. What does that mean? That's kind of like saying 0.85 meters per second, okay? And that means that every second she increased her velocity by 0.85 meters. Okay, but there's our answer right there. Now, the second thing we're being asked for is force, okay? After she speeds up, calculate her force. Now, again, I'm gonna write my formula. I'm gonna write what I know first. Force equals mass times acceleration. And let's figure out what we have. Well, we have acceleration. Acceleration, we just calculated. You know, we're good to go for that. And we also have her mass. Her mass is in kilograms, 869 kilograms. If you're given a mass and it's not in kilograms, you definitely need to convert, okay? But we have 869 kilograms, and then we're gonna multiply it times her acceleration. And her acceleration was right here, so we have 869 kilograms times 0.85 meters per second, okay? And we do our calculations. Boop, 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 boop. Always bring a calculator. We have 738.65. Don't forget units. The units for force is going to be newtons. And wham, bam, we have answered our question fully. Let's double check. You know, what were we looking for? We were looking for force, calculate force, and we were looking to calculate acceleration. I've showed my work. It's all logical. We are good to go. Thank you for listening and have a great